In this segment, we will take up a problem which is shown here. Basically, we will practice how to represent a vector. In this example, this tension T. I'll explain the problem. So that's the practice which we will do, how to represent a force in mathematical form, okay, as a vector. So this problem tells you like this, okay. So there is some block, this green one, and then on that maybe with some hinges, this blue color board is attached, okay. Maybe these are some hinges. Okay, so some like this, there is a hinge, maybe here also there is a hinge, okay, and it is attached to this board with these hinges. Now there is a string which goes from this corner A, the board is ABCD, which obviously must be having some weight of its own, and there is a string that connects point A to this point E, which is the midpoint of this length. Maybe I can say CF or something, whatever. CF is the length, whatever is the length, at the midpoint of that this string is connected. And it is also known that a tension of 300 Newton is existing on this string. Okay. And we the question asks us to represent this tension as seen by the point A, okay, as a vector form, okay. We want to represent that as a vector. That means we want to represent, I'll change the color maybe, we want to represent T as a vector, maybe something times I plus something times j plus something times k. So this is the main goal, and for that suppose we choose a coordinate system which maybe runs like this, say this is x axis, so this is y, or the question gives even the axis, so this is given to be the y axis and this is the z axis, okay. So this is the axis definition, and with respect to this axis we have to figure this out, okay, and I, j, k's are unit vectors of this. Now as we know, we have to go from the tail to tip, and okay, first thing is this picture represents this force pictorially, okay. That means now the unit vector is represented by the picture and the magnitude of the force is given as a number. So that means we are supposed to first find out say T magnitude and T unit vector. So T will be represented like this. Is the easiest way to do that because the magnitude is already known. So that means only thing, so I can write it here, that 300 T hat. So only thing now we have to do is to find out this T hat. Now T hat will be represented as, I'll say T hat will be represented as the geometric arrow. If I say AE is the arrow divided by the length of AE, okay. So that's how we will calculate. Now to find out AE vector from the geometry, the arrow, what we should do is, from the general method, from the tail to tip we have to move by following the axis, okay. Now so we start from here. Let me put some other color maybe, yeah, so whatever, this one, yeah. Now we can move in suppose we start moving in the x direction, Okay, our aim is to reach this point, but by moving parallel to x-axis. So I'll first move in this direction. So I'm in the same plane as E, and then I will try to move parallel to y, say, okay, up to just till the point when I go below this, and then I will move to this point in the z direction. Okay, so this is the path which I will take, and just to make the things a bit clearer, I'll just draw the picture as you are looking from this side. Okay, so if you look from this face, the board is hanging something like this. Okay, this angle being 25 degrees, this angle is 25 degrees, and the string is attached from this joint to somewhere here. Okay, so like that. And the movement which I am talking about now, so you start from A to B, so both A and B are here, so you are going inside the plane, and then these two lines we are just moving like this and this, so they are clearer here. So amount that you move in the y direction is this, and the amount which you move in the z direction is this, and the moment you move in x direction is this. So they are in a way A, E arrows components. So I'll say A is x component, then this is A is y component, and A is z component. Okay. Now, so that will give us the vector AE as an arrow, and then we just have to divide by its magnitude. So what we can write here is, now suppose x direction we have to move by how much? This is 400 mm. So minus 400 I, because we are moving in the negative x direction. And then in the positive y direction we are moving how much? This. Now what is this distance? This distance is this length, right? So this is the length which we are talking about. Now that how can you get it? By say if you take the cos theta component of half of this length. Okay, so now let's say I am writing here that A is y component will be 600 cosine of 25 degrees. Okay, so that means, because so this length, this angle also is 25 degrees. Okay, so that means, and then this length is 600 cosine of 25 degree will give us the value of around 544. Similarly, AEZ in the D direction, so that is this full length. Okay, so this is that length which I am talking about now, and this is what if you see the sine component of the full length AD, right? So this is equal to this. This is nothing but the sine component of that. That means 1200 sine of 25 degrees, which will come out to be 507. Okay, so that means these two things I can put here to get in the positive y direction. So that means this plus 544j and plus, I'll shift it a bit so that I can get some space. Okay, yeah, so then yeah, plus 507k, right? So this is the vector A, the arrow now you have represented, and divide by AE dotted with AE. Okay, so that means you get so I'll write that as AE dotted with AE, and you know how to get it. So this square plus this square plus this square, and then once you get this, so square root of that. Okay. So length square you will get, and then its root. So if you do that, you will get t hat, and again I'll do one thing. I'll move this much also a bit. Sorry, did I erase them? Okay, so sorry, it's not working properly. Maybe, yeah, that's fine. So just replace this thing here, and you get the answer. That is, I'll write it here. That t vector, you will get it to what? So 300 times minus 0.474i plus 0.644j plus 0.601k. So this is what you will get, and that's the thing. So this is t hat, and then so this is the way to represent any vector like force in this case in mathematical form using the unit vector representation. And then this is useful, again I am repeating, when the magnitude is known otherwise, and just the unit vector information you have to get from the geometry of a picture. So see you in the next video with some other problem. See you.